Alrighty, hello everyone. So in this video, I'll be covering the cross-section editor in the Allegro PCB design environment. And you can open the cross-section editor by clicking this button here up on the top. And upon doing so, you will be presented with a screen as follows. So in this particular example, it's a fairly complicated stack up. This is referred to as a multi-stack up because I have essentially defined different stack ups based on the region of the board. So in this display, I have everything visible in one window. If I were to selectively look at my primary stack up, you can see this is the definition, right? So I have 4 conductor layers, 2 plane layers, and 8 masks for a total of 14. And then if I were to go specifically to the flex region, right, it's a reduced layer count. So here the focus is on 2 conductor layers, which is primarily just the inner regions, and then 6 masks, 4 on the top and 2 on the bottom. Similarly for the flexi stiffener, right, a reduced layer count, and also the LCD stiffener, a reduced layer count. Now you'll note that the reduced layer count actually has a dielectric which is of the material type known as polyimide. And this is a common material that is known to be more flexible in characteristics as compared to the traditional FR4, right? And if I do a comparison here and then the all stack up region, you can see that for my dielectric between the top and the ground, which is layers 1 and 2, I selected FR4, right? It's rigid and of course cheaper than polyamide. And then for the internal layers, which continue into the flex region of the board, they are of the type polyamide. So careful selection needs to be done when defining your stack up, right? And it's often an iterative process in collaboration with the PCB vendor that you'll be fabricating with, and they'll help you in guiding how to select appropriate materials, copper thickness, any kind of trace requirements you have for routing, right, impedance constraints and so forth. So all of those things will have to be ironed out along with your via specifications as well, right, whether you need any laser drilling or your end-to-end through holes are sufficient for your purposes or not. So we'll do a deeper dive in a future session on that topic. But in terms of actually setting up the stack up, this is how and where it will be done. All of these cells are individually editable. And once you make the proper selections and you're satisfied, then you would simply just click apply and OK, and you will see your design environment update to reflect your new selected stack up details. Okay, so that's a quick introduction to the stack up editor. One more feature I did want to highlight is the capability to actually import these different formats of the stack up information. One very convenient method, which is gaining a little bit of traction in the industry, is this IPC 2581 format. This, you should ask your PCB vendor if they can provide the stack up information in this format file, so you can readily just import and get all of the information with a single click. Otherwise, historically, vendors have been providing Excel sheets with all of these cells updated, and then the designer needs to go in and replicate that information within this tool as well. And you can understand that's a bit of a time-consuming or error-prone operation. So I highly recommend exploring this IPC 2581 format with your PCB vendor. Okay, so once I have the multi-stack up information set up in the tool, the next step is to basically assign zones or regions within my board that will make reference to these individual stack ups. So as an example here on the left-hand side, you'll note that I have a number of different regions that are highlighted, right? And the name gives me some indication as to which stack up they will be referencing. So for example, the main PCB, which is the rigid portion of the board, will be my primary stack up. The LCD, flexi, and another flexible portion here will be mapped to my flexi 1 stack up. And then the stiffener regions will be mapped to the appropriate stiffener stack up as well. So flexi stiffener and the LCD stiffener. So the way to actually go about and setting these up is to go through the setup menu here, go down to the zones and click create if you're starting from scratch, or in this particular case, I will just click the Manage button here to show you the definition that's being mapped here. So as I mentioned earlier, right, my main PCB is linked to my primary stack up. The various flexi regions are linked accordingly, and same with the stiffeners. So this is where your linkage or mapping will happen, and you will be able to then start utilizing all of your routing constraints based on which region of the board you are working in.